Labadina. Good afternoon. I'm honoured to be here with you all today at Innovation Drift. It's a bold and exciting event that I'm sure is bound to help Lithuanian innovators continue to develop new and compelling technologies that can change the way that we live for the better. My name is Jonathan Wiggin, and I'm one of the founders of N-Wave, as Saulius kindly just told you. We've developed communications technology, hardware, and solutions for the Internet of Things. I'm going to be talking about what the Internet of Things is, the potential size of the opportunity that it creates, some of the obstacles in the way, Lithuania's place in the global innovation picture, and sharing my thoughts on the biggest opportunities in the sector. I will mention different types of communications technologies and the work that N-Wave has been doing in this field. And finally, I will be giving you some ideas about how you might put together strategies for creating smart, connected products. So what is the IoT? What makes it different from machine-to-machine communications or telematics, both of which have been around for decades and are used in many different industries? Put most simply, machine-to-machine communications allow devices to communicate with other devices of a similar type, often within closed systems using proprietary technologies that are not interoperable with other systems within the same company, the same industry, or within the larger machine-to-machine universe. The Internet of Things, on the other hand, allows things not just to communicate with other similar things, but also with things with which they may have previously had no interaction whatsoever. So now we can envision a world in which a smart connected orange in the supermarket can communicate with our smartphone to tell us how many kilometers it's traveled in order to make its way into our shopping basket. It can tell us what tree it was grown on. Before getting there, the tree that it grew on was probably communicating with smart irrigation systems, which in turn were communicating with environmental sensors in the field. The same orange can possibly communicate with the lorry that brought it to the supermarket, and the lorry might at the same time be communicating with fuel sensors and intelligent signage. And when we get that orange home, it could be communicating with our fridge or with our air conditioning system, and then the air conditioning system could be communicating with the energy provider, which might in turn be communicating back with the irrigation system on the farm. All of these interactions, however, don't just provide information that's relevant in a single moment. But when combined, all of these pieces of small data can be analyzed and can provide new insights into how our world operates, open up the potential for new efficiencies, and create disruptive new business models. The potential for change is impossible to measure, as the insights from the big data that is made up from all these pieces of small data are not all immediately obvious, and the sheer quantity of data can only be handled by advanced computing, dealing with infinite combinations of data brought together from billions of different sources. Depending on who you listen to, there are going to be 20 billion or 30 billion or 50 billion or 100 billion connected devices in the next few years. It doesn't really matter what the figure is, and if you can't read the small print, that's not important either. The important thing is that you see this upwards exponential trajectory. And the changes that this explosion in the Internet of Things are going to bring are going to be felt in every part of our lives, from energy and transport systems to health, agriculture and government, even down to things such as child-connected toys. And in fact, today I've met some fascinating people doing something in that field, a mixed German, Lithuanian, Polish company, I understand. An example of one of the areas where the Internet of Things is going to bring huge benefits is in the public sector, with enormous savings to be made through more efficient, smarter cities, in which buildings use less energy, transport systems run efficiently, and citizens are able to lead more efficient, more productive lives. For example, $100 billion can be saved annually through Internet of Things approaches, allowing buildings to use less energy. But this is just the beginning, and there are many other potential benefits in areas in smart cities applications like smart cities, smart connected lighting, smart utilities meters, connected cars, connected health devices, and environmental sensors. So, who does the Internet of Things impact, and why should we care? For manufacturers and OEMs, the IoT impacts business models, the entire approach to service, channels, partnerships, and their relationship with their customers. For solutions providers in software, hardware, and telecommunications, this means a race to create new products and capture these massive new market opportunities. This means they need to change their products, their relationships, and their business models. So there's a lot of work to be done. For third-party service providers, such as those in logistics, field services, oil and gas, packaging, the IoT impacts the delivery model and the types of services, including real-time services, embedded intelligence, and big data analytics. For systems integrators, the IoT impacts not just systems integrators for information technology, but also systems integrators who design and integrate manufacturing plants, oil platforms, campuses and facilities, power generation, and so much more. And finally, for end users, the IoT has proven its ability to provide substantial savings in energy use, cost of operation, safety, literally saving lives, tremendous efficiency gains, and much more, no matter what sector the company is operating in. So this all sounds great, doesn't it? But what's stopping this happening? I've been working in the Internet of Things for a few years now, trying to make this a reality, and it's not happening as fast as we would hope. According to a Cisco survey, and I have great respect for Cisco, a bunch of C-level executives, they say that the biggest obstacle to the development of the Internet of Things is a lack of adequate communications infrastructure, followed closely by a lack of capital, a lack of government support, a lack of customer demand, and an inadequate number of skilled workers to make this happen. Now, while all these sound like relevant and insightful comments, I would say that the biggest challenge in the introduction of new technologies is always inertia. The choice of doing something new and taking a risk, or simply doing nothing. And it is these same C-level executives who are often to blame. Beyond the problem of reluctant business leaders, I would say that we have pretty good existing communications infrastructure to implement Internet of Things applications, whether that be existing GSM mobile technologies for long-range applications, or short-range technologies such as Wi-Fi and Bluetooth in the home. And then there are other technologies such as N-Wave Zone for low-power wide-area communications, which can be rapidly and cheaply deployed. In my opinion, the problem is more about making everything talk to everything else seamlessly. The Internet of Things has to be based on standardization, harmonization, and interoperability in order for it to reach its true potential. We also need to confront the important issues of data privacy and data security and educate the people who make decisions in companies and governments so that those decisions are based on clear business cases. If we take a look at the Global Innovation Index created by Cornell University, and I encourage you all to check out their website, it's a really fascinating tool to allow governments to make exciting decisions how to push innovation forward. We can see that all European countries are in the top 100. Switzerland and the UK are in first and second place, while Lithuania ranks at a very respectable 39th out of 143 countries, comfortably ahead of Russia, which is in 49th place, and just behind China. So Lithuania is in a really excellent position to take advantage of a fertile innovation environment and reap some of the massive potential that the Internet of Things offers. I've been to the Baltic states a lot over the last 15 years, and each time I come back, I am truly astonished by the pace of development. And innovation and technology is one of the areas where I've seen this most. The Lithuanian innovation strategy defines a number of breakthrough areas and technologies to concentrate on. And those of them that I feel are most suited to Internet of Things approaches include ICT, obviously, clean technologies, future energy, health and well-being, transport and logistics, wood and forestry, textiles and food industry. The forestry industry, for example, is an area where I can see the Internet of Things bringing enormous benefits. And I know what I'm talking about because I spent several years in the forests in Siberia seeing how it can be done wrong. It can be improving things right from the beginning, from connected environmental sensors preventing forest fires, to improving sustainable forestry practice, to increasing productivity and lowering costs in the factory, to tracking timber as it moves along the demand and logistics chain. As you can see from this graphic from Beecham Research, and once again, don't bother trying to read the small print, the scope of possibilities for the Internet of Things is almost endless. And these new technologies and approaches can be applied to almost every area of human endeavor that we can think of. But what many people forget when they think about the Internet of Things is that they fail to appreciate that any Internet of Things solution is made up of a full stack in order to create that complete solution. So what this means is that whether you're an application developer, an electronic engineer creating edge sensing devices, a security expert, a UX developer, or a radio engineer, there is an opportunity for you in the Internet of Things. And as solutions become more complex and mission critical, platforms need to evolve in order to keep pace. More intelligence is being shifted to the edge of the network. And where in the past companies tended to create full stack solutions in-house, they're now looking to get the best of all worlds by getting one little bit from that company, one little bit from that company, and another bit from over there. And so what this means is that smaller companies, startups, if they're experts in their own particular area in the Internet of Things, they can work together with larger companies, forming partnerships to create their own solutions and take them to market. But every stack needs data transport, and that means connectivity. As you can see from the graph on the left, it looks like short-range communications are going to be providing the vast majority of the connectivity for all of these connected devices. But if you look on the right, and we're talking about long-range connectivity, we can see that low-power, wide-area communications is predicted to be the driving force. Which brings me on to what we do at N-Wave. So, on one end of the spectrum, you've got technologies like Wi-Fi and low-power Bluetooth. They're energy efficient, which is great, but they've got dreadful range. On the other end of the spectrum, you've got long-range technologies like GSM. They're long-range, which is great, but they use a huge amount of power, which means they're unsuitable for a wide range of IoT applications. So what we need is a communications technology which combines long ranges with low power consumption. So our ultra-narrowband radio technology, working in sub-gigahertz unlicensed spectrum, is long range, giving ranges of up to 10 kilometers in urban environments and even more out in the countryside. It's also low power, 100 times less power than mobile. And this means that devices can operate off a single battery for several years. Our technology is opening up disruptive new business models and helping solve some of the most serious challenges facing modern society. One of these is agriculture. Every year, 3,000 trillion liters of water are used in agriculture, of which 1,500 trillion liters are wasted. By connecting soil moisture sensors using our technology, we can help farmers reduce water usage by up to 40%. And the scale of a market for this solution is huge. Did you know that up to 30% of urban driving time is spent looking for a place to park? By connecting parking sensors using our technology, we can help drivers find a place to park fast. Cities benefit from improved enforcement, and we can all enjoy reduced pollution. But these are just a couple of the areas where we can bring benefits. And market analysts predict by the year 2023, there will be 4 billion devices needing a technology like ours. And if you take a look at this chart by Machina Research, the only analyst group dealing exclusively with the Internet of Things, you'll see that the number of different application areas covered by low-power wide area communications is huge. There's an enormous tail there. Now those little dots may look pretty tiny, but when you measure them in the hundreds of thousands or millions of devices, it's not as small as it looks. And there's everything there from white goods, microgeneration, well monitoring, transport, agriculture, you name it. We don't just have a technology at Enwave though, we also have the hardware building blocks to enable companies, individuals and governments to build the solutions that they need. And that's the first source of revenue for us. And behind these hardware building blocks, we have the advanced back-end and front-end systems to make solutions that work for our clients and give us a scalable, repeatable source of recurring revenue. But in order to make clear recurring revenue, you need to have clear routes to market. And we understand that to get serious revenue, you need to work alongside serious companies. So we're working with companies like Accenture, BT, and Cisco. We also understand that in order to penetrate individual industries, we need to work alongside experts in those industries to leverage their relationship and expertise. And so we're working with partners in agriculture, parking, and waste management. And apart from that, the positioning of your company is very important, and we think we're positioned to win. Firstly, we're committed to democratizing our technology, which we've contributed to the world's first open standard for Internet of Things communication. This means we can tap into a global pool of developer talent, accelerating adoption. Also importantly, our technology allows thousands of simultaneous transmissions, not just tens, which is absolutely essential for the high-volume applications that the Internet of Things demands. And this scalability is essential because we're growing rapidly. We've already deployed networks in the UK and Milton Keynes for British Telecom, in Denver, Colorado in the US for parking management, in London for Cisco, Oxford for Nominet, our first Danish networks in Copenhagen and Esbjerg, and as we grow, we'll be taking on more of our pipeline worth an estimated $30 million in the next 3 years alone in Europe and the US. But enough about Enwave. How can companies create an IoT strategy that works? First, you need to work out what use cases you want by looking at how connected products and connected operations can change your business processes. Then you need to work out what the value proposition of the use case is to the business or customer, and compare that with the inherent risks associated with implementing the solution. Once you've done this, you move on to developing your business models. Here there are some key elements, and I think that one of the most important of these is making sure that you have support at all levels of the top management. So often people come up with a great idea, the chief of innovation, he's all over it, but the guys who look after the finance, who look after the management, they don't understand the benefits, so you have to get them on board. You need to create a vision for connected products and operations. You need to define how you're going to monetize these opportunities. And to make this work, you need to look at involving all the different parts of the business so they understand everything right from the beginning. You don't just involve those parts of the business that are building the solution. Once you've worked out what to do, you have to pay for it. And I think that the best way of doing this is to involve the particular line of business that is going to benefit from the solution. and then make sure that each functional area thinks about and understands these benefits. Once you've done this, the job of sharing out the expense becomes much easier across the business units. And most importantly, you'll have made each different area of the business feel empowered, feel that they understand, instead of worrying about complexities that this new technology might bring. But finally, when all's said and done, it's all about the money. It's all about the financial potential of solutions. And no Internet of Things product or solution can be successful if the people and companies creating and selling it don't know the metrics that are behind it, if they can't articulate clearly the return on investment and how that is made. So that brings me to the end of my presentation, and I would just like to add some final thoughts about current tendencies in the Internet of Things. The Internet of Things is all about the interoperability of connectivity technologies combined in solutions in an optimal fashion, and about solutions that can interoperate smoothly with each other and other enterprise IT systems. Internet of Things solutions are increasingly seeking to create new services and new business models, rather than simply enhancing cost savings from existing operations. IoT solutions are also becoming essential, mission-critical parts of how businesses, governments, and individuals operate, meaning that in turn, the approach to security must be seen differently and made a top priority, supporting solutions and combinations of solutions that are strategically necessary for economic and social development globally. And with the move from machine to machine to the Internet of Things, with its associated move from monitoring to control and towards richer applications, much larger amounts of data are produced, which need to be transported, processed, and stored. Much more of this processing will be taking place at the edge of the networks, and the data produced will be used across sector boundaries, hopefully in ways so intelligent that we can only begin to imagine them now, but that will open up the full potential of the Internet of Things, helping to create a better world for us all to live in. Thank you very much for your attention, and I hope that some of the things I've said resonate.
Thank you, Jonathan. It's time for questions. So please present yourself and ask the question. Okay. There must be somebody here. Okay, I see one. Give me a second. Yes, the microphone is coming. Please present yourself and ask a question.
Hello, my name is Pius. I'm a mechanical engineering student. I would like to ask a question, maybe a little off topic, but what do you think about the security issues that will be arising when we have, let's say, a full-fledged Internet of Things available? I mean, if one operating system was supposed to be running everything from traffic lights to hydropower stations, I mean, I see a lot of potential issues in this question. Would you please elaborate on this if you can?
Sure. It's an extremely good question. I try to emphasize the importance of security. And this is actually an issue that comes up increasingly often, because we've now got many ideas about how to move the data, how to store it, how to analyze it. But as you say, what's going to happen if a building's got smart connected locks, a smart connected thermostat, your car is connected? So there are a lot of companies that are now working specifically on security for the Internet of Things. Security has to be implemented at every single level in the stack. It can't just be there at the operating system level. I think it's also important not to just look at the operating systems, but to look at the data transport layer and to have backup systems so that if one does fail, there can be another way of getting that data out. I'll give you an example. So security companies, often in their security devices, they're using mobile SIM cards to get the data out. However, that's something that can be jammed and interfered with. So as backup, they might be thinking of porting some other kind of data transport protocol onto the chip that's already in their devices to make sure that if there is a security breach, they can still get that data out.
Okay, thank you. One more question, please. Yeah.
Hi, my name is Justina from Bike company. I have a question regarding the range. As you said, it's until 10 kilometers. Is it possible to make it bigger, for instance, connecting to the mobile devices? And is it possible to connect to existing devices?
Yes, it is. I mean, it depends upon the devices. In general, low-power wide-area communications, they're dedicated to transmitting small amounts of machine-generated data. So it's not suitable for video transport, for example, or voice. But for small amounts of device data, it can connect with existing devices depending on the silicon that you've got in there. You can do an over-the-air firmware update. You can port the protocol onto the existing silicon, so without any physical interference with existing devices. In a matter of minutes or hours, you can create an entire new data transport system.
Okay, thank you very much. And the one last question, please, over here.
I'm Laura from Ministry of Economy, and I have a question. I mean, your system needs electricity. Imagine we have a smart house and everything is connected to the system, and electricity is disconnected. What happens? How do I get out of the house? How do I put up the, I don't know.
That's a very good question. So, firstly, I'd like to recall the idea that because of the incredibly low power consumption of this system, it means that devices can operate, beg your pardon, from batteries for several years. So, for example, a smart water meter can operate from a single AA battery for 10 years. So there's no need for mains power there. But if you're talking about the transceiver, which is receiving and sending messages, this only uses about the same amount of power as a single 40-watt light bulb. So there's plenty of potential for backup systems using batteries or solar energy or other forms of energy to deal with situations where the mains power might go down. And in fact, we've had a lot of interest from countries looking at early warning systems for disasters, where they're worried that power systems might fail and they need this kind of backup connectivity to allow citizens to get information about what's happening, where to go to, what's going on.